website. Why not do it yourself?
Jeez, come on, YouTube, really?
Hey.
Oh, the cat's meowing. All right, let's go. Let's do this thing. All right. And welcome to Descalate Data. And our
Cat edition.
And our cat.
And a cat. Okay, well, he kept meowing and
Yeah.
he wanted something. So
All right.
now he's annoyed. He's going to go.
Okay.
All right, so we're having a little bit of a late
Happy
night.
4th of July, everyone.
Freedom Day.
The fireworks
We still
are
have 15 more minutes of freedom.
going on, yeah.
There was fireworks. I thought we would show some Fritzing board generator fun. This is something that Phil B's been working on. And I thought, I've been doing this all day, so why not do a little bit of it on camera? What do you think?
Yeah.
Good times.
I think you should talk about what Fritzing is.
Yes, we will. So let's go to the computer and I'll show it off.
Okay.
It's that easy.
Hmm.
Okay, so I've downloaded, oh, sorry, this is the old version. Fritzing here, and this is, yeah, it's going to complain because I'm in the middle of generating files. It is software that you can use to create custom diagrams, which is what I use it for, but it can also be used for schematics and stuff. And like you get a breadboard, kind of like when you breadboard electronics. You can change the size of the breadboard, so that's kind of nice. So half-size breadboard. You can even rotate the parts around. So it's a little bit like a graphics program. And then what's neat is that there's this whole library of parts that you can use. Like, let's look up an Arduino. There's just a lot of Arduinos. Searching, searching, searching. So like you can tell there's like Galileo and Yun and Pinocchio and like, you know, Arduino motor shield. Let me see if I can find, like, this is a Mega wireless. Oh, here you go, Uno. So we can drag this over here, and now we've had this like really lovely diagram of an Arduino. And what's neat is that it's like a smart diagram. So let's say I wanted to wire up an LED to like pin 13. I can actually click on this pin here and drag it over, and it'll create a connection. And then I can like wire up a ground wire. And I can even make this wire black. And then if I want like a power wire, I can drag that over and make it red. That's kind of nice. And then if I look in the core, there are a whole bunch of parts like, you know, like a resistor. So you can take a resistor, rotate it. Okay, so now we need an LED, like this one. And then rotate it, and then let's flip it. Oh, can I flip? I think there is a way. Part, yeah, flip, horizontal, no, that's fine. So you can see there's the long pin is for the anode, and then you can, you know, wire this up, and now you've got just a LED connected, and that's always just fun because it's like a really lovely diagram. Like you can, if you click on control, you can even make these a kind of nice rounded wires, so kind of simulate what a wire would look like. Those are nice splines. And then in schematic view, you also get, you know, schematic basically. So you can draw, and then it will create a schematic for you, and then you you just tell it to fill it in, and now it's filled in. You can, I mean, it's a very basic schematic editor, but what's neat is the breadboard view and the schematic editor are tied together. So you know, if you draft it on the breadboard, it shows up as schematic and then as a PCB as well. So if you want to make a custom shield, you can do this and route copper with just lines. It's very simple, but it's very effective. It's a lot easier than EagleCAD for people who really just are like, look, I want to get the, you know, 4 LEDs on a shield and a button. And if all of those parts are in Fritzing, it's very easy. So let's just save this as my LED demo. So the good news is that, you can have all sorts of components from like an LCD, and like the LCD, like maybe has even, some parts have settings. Like this red LED, you can change it to be yellow or like green. So that's kind of cool. You can customize the parts. But you actually, because of the beauty and elegance of this, it takes a little bit more effort to make parts. Like with the EagleCAD, it's very easy because it's just very mechanical. You just have to measure all the pads out. With, you basically you're basing it off of a data sheet. The data sheet tells you the part's 3 by 3 millimeters. It has 0.5 millimeter pitch. These are the size of the pads, and it's like very straightforward. It's like a bunch of rectangles, very easy. As you can tell, drawing an LED or drawing this Arduino is a lot more complicated. So we do have an Arduino, we have a Fritzing library and all these Fritzing parts. I'll just open the whole library so you can see some of the parts that we've got. And what's nice is these are all vector graphics, so it prints very beautifully. You can export to PDF. So it's really quite lovely. You can zoom in and out. So if you add like the Adafruit collection, you can add your own custom parts. Like today, added a feather Ada logger. So you can let's make this a full-size breadboard. Oh, I did not like it when you do that, so you have to redraw the parts, I guess. Okay, so you can, add some Adafruit parts, but like drawing all of this, because it's not like you're just drawing a rectangle with, little pads everywhere. You actually have to draw all these resistors and capacitors, and you have to make these like connections. And then some connections are special, like this ground is shared with this ground. So you see when I click that ground, this ground lights up because it's the same electrical connection. And then here's the PCB file for this. So these are a little bit more complicated than just EagleCAD objects, which are very, very simple. So we kind of didn't really make parts, Fritzing parts. Like we hired people to do the graphics and do each Fritzing part, but it would take like hours to do each one. It was very time consuming, and it was very picky, getting everything lined up and naming everything properly. It's very tedious. It is. I mean, they're lovely, lovely parts, but it's very tedious to make them. And so we would be lucky if we could get someone to make maybe even like 2 or 3 a week. That was like a challenge. And also, like, people are like, I don't want to do this. I want to do something else. After we have like 250 components that we've made, so like that's a lot. So 3 weeks ago, Phil B and I were talking about this, and I was like, Phil B, I don't want to make these parts. And he says, I don't want to make these parts. Nobody wants to make these parts, but we have to make these parts because we want to do this. It's true.
Nobody wants to make these parts.
Nobody wants to make these. Trust me, this has been 3 years of trying to find somebody to make parts. And actually, what I did do is I hired Pig Hicks to make these lovely diagrams.
Yeah.
So I'll show you
Oh, are we going to use the overhead tonight?
Yes, in a little bit.
Oh, in a little bit? Okay.
Yeah, in a moment.
All right. And just one little programming note. The live Jupiter.
The Juno thing's happening?
Yeah, Juno it's the insertion is happening in like 20 seconds, or 20 minutes or so.
Okay, good. We'll
and
done.
So we can cut over to NASA.
Okay. What's cool is you can broadcast this.
Right. This is one of the few things you can rebroadcast.
Yes.
I wonder if they're watching your show while, hey, look, this guy, hey, I found Waldo. There he is, upper left. There he is. He's at the Juno mission. Okay, anyways.
Okay.
So we have that going on.
Okay.
Well, if we need to cut to it. Oh, look at this.
That's like you. You got your hair.
What's neat is like they're live broadcasting and we're live broadcasting. I should tweet out.
I know, and I'm not going to Jupiter. That'd be cool.
Although we're not, we can't confirm or deny, but I could say many space agencies purchase from Medford.
It's true.
Okay, back to the fun.
Okay, so the one thing that I did get though, which was awesome, was we hired Pig Hicks to make some lovely diagrams. So like this is kind of nice because this is a PDF format, so we can actually grab components if necessary. Like if you're like, oh, I need a really nice drawing of a micro SD, like he made like gorgeous drawings of a micro SD holder and a JST and a USB jack. So that's kind of nice, but it's still not like a Fritzing object. Like even taking this, even if you have like a beautiful diagram, taking this and turning it into a Fritzing diagram is quite a bit of effort. So we will use this tool. And let me remember where I put it. I put it in projects, Fritzing. Okay, so this is the Eagle to Fritzing tool. And if you go to GitHub, Eagle to Fritzing. So we forked this from Fritzing's repository. They actually wrote this tool. And basically it can take an EagleCAD BRD file and it converts it to an XML file and gives some manipulation. So you could use this with KiCad. You would just have to figure out how to convert the KiCad XML into this XML. And then it will actually locate all the components and draw them into like an SVG. So I'll show you like, I mean, this was like 3 works of effort to get it to do this. So Phil B did an amazing job. But basically we have a, I have a little script. There's a script with a script with a script. There's like a lot of Python scripts. Basically, you call EagleCAD to make this XML, and then you call a program called preprocess to preprocess a file, which does some font work to rearrange the fonts for you a little bit, which is a detail that to make the text look beautiful, you have to kind of mess with the font spacing and stuff. And then actually calls this tool BRD to SVG, which is the tool that Fritzing wrote, and it's very tuned to SparkFun parts, because I think it was written for SparkFun to generate their components, but I don't think SparkFun ever ran it, because the board output, like once we got BRD to SVG into like a good location where it's generating stuff, the parts that it generates don't look anything like anybody else's parts. So we're not actually sure that anybody's uses, but whatever. Yeah. That's all good. Let's run this. So let's go to the overhead, and I'll show off the part that I thought we would do.
Okay.
So this is the MMA 88451, and it's a very small accelerometer that we put onto a breakout board. So this is something that people would want a Fritzing part for, because like you want to use it with your breadboard and you want to like emulate or diagram it connected to like a this Metro Mini or an Arduino or an ESP8266, whatever you want. But you have to, again, get this drawing made. So let's go to our, okay, so it's just computer now. That's the only overhead thing.
That's it?
Well, yeah, pretty much.
Okay.
Okay, so in our breakout board, sensors, MMA 88, yeah, I mistyped it, but it's 8845. And we have a directory. Oh, this is the backup. Okay, so this is the directory, and I'm going to put this file here, and I'm going to rename it, because first off, I've noticed the code prefers underscores, and also I don't want the revision code to be in there. And then I run, this is like my test directory. I run this, and you saw it like flashed EagleCAD, and what it does is it goes through all of the components that are in the EagleCAD, and like, oh, an 0805 resistor, okay, good, 0805 capacitor, and it finds these subparts. And when it finds all the subparts, it puts them into the final drawing. And it doesn't find the fiducial. That's because the fiducial it's not a component, it's just it's a copper dot. It doesn't find the connector, but that's fine, because I don't want the connector to be in place. It did find SOT23s, and it didn't find this custom part, which is the custom component I made for the MMA, the QFN 16 millimeter. 16, 1 point, it's probably 1.6 millimeter. I mean, I don't know. I don't think it's that big. I don't know. We'll figure out why it says that. So this is what the board file looks like. I'll turn off the measure, and I'll turn on the T-stop or T-docu. So this is what the board looks like in EagleCAD. And then let's look at what it generated. So it puts the part in parts, SVG, contrib, breadboard. You can see I was working on Circuit Playground. And then I use Inkscape to look at it. So this is what I got. So that's pretty freaking close. Like I got the 2 resistors here, 2 resistors here, the 2 SOT23s, some capacitors, a SOT23, 5. I prefer it without the header spots in. It got all the silkscreen. And it got this. It did kind of misplace the Adafruit logo, but luckily that's really easy to fix. You just ungroup, and then you can just grab this and just drag it. I don't know why it always misplaces that. And then you can also, you can ungroup and, oops. If I want to move this A a little bit closer over here, just so it doesn't run to the end. If I want to move this V in text, I can do that too. So you can mess around with it. It's a scalable vector graphics device, but it is missing a component. It's missing this QFN here. So what we can do is create that subpart, and then going forward, anytime we want to make this component, we just use the subpart. So it's in subparts, and subparts has all sorts of cool stuff, like it has the EG 1390, which is a slide switch. So it's a slide switch drawing. And it has a JST-PH. So, you know, some parts we've already done. Like this JST, or we have a component for the Bluefruit module. So it just means that every time we make a Fritzing part that uses this Bluetooth low energy module, this will get dropped in place. So that's kind of nice. That is an elegant way of doing it. It's a lot easier than having to redraw the whole thing over and over again. The nice thing about this QFN is QFNs are really, really easy to draw because they're squares. So for example, maybe it's a 16-pin QFN. Maybe this part is close enough. Oh, I'd say it's 16 millimeter. And why has this got extra stuff here? I do not know. Let's grab this QFN, and then we can just rename this, and we'll see if this works. Just create a new part, copy and paste a previous part, just make sure it looks good. And what's neat is these parts are exactly to scale. Like this component, let me put it in millimeters mode. So this component is exactly 2.4 millimeters by 2.4 millimeters. Let's look up that MMA 8452 component. Let's see. Oh, it says at the top. It's 3 millimeter by 3 millimeter by 1. Okay, great. That's pretty easy. So we can resize this to be 3 millimeters by 3 millimeters. And then if we want, we can even put like an adorable little pin 0 marking or pin 1 marking. I think pin 1 was always bottom left. And then we just have to redraw the canvas. So I use this handy little thing. Just resize page to drawing. And bam, that's it. That's a new part. So then when we rerun this tool, it's going to say it found the subpart. Wow, found the subpart. And then we can reload this. Unfortunately, you'll lose your previous changes. Okay, so looks like close, but like first off, the dot's in the wrong location. So let's fix that. And then there's always like it's a little bit offset. I don't exactly know why that is, but I've noticed it's always a little bit off. Let's regenerate this. Okay, and revert. Okay, well at least the dot's in the right location. So that's really nice. Let's we'll come back and edit this first. So the first thing you want to do is get all the subparts, even if they're not in exactly the right location, just get them to appear. Once you do that, you want to work on the, hold on, there's just so many parts here. Close this window. Okay, next you want to do the schematic. So let's check out what the schematic looks like, because this tool generates all three, the PCB, the schematic, and the PCB schematic and the breadboard look. So this is pretty close. I do want to do some light editing to this, which is I want to change this to say VN, and I want to get rid of, even though this is 5 volts, it's actually like 3 to 5 volts. So that's kind of nice. Okay, so that's a little bit better. So that's a schematic, and now that I know the schematic is good, ironically, you go back to the breadboard and clean that up, because if you have to regenerate the schematic, you end up overdoing the breadboard. So ungroup, and then kind of just like slide all, I mean, like, it's a little annoying, but it's a way easier than drawing everything by hand. There's a lot of groupings. And then, there you go. Okay, I think that looks pretty good. There you go, that's perfect. Okay, sweet. So now I'm actually pretty close to done. All I'm going to do is I open up my Fritzing folder in Documents. And then there's this area called Parts. I'm going to delete everything out of it because you have to kind of start fresh every time. Paste in those parts, and then you start up Fritzing. And it's going to complain, which is normal. And then if you search, and my previous search is there, so I have to hold on. This is the MMA 8 something something. So here you go. So this is the part. And we're really close. It's not perfect. For example, it doesn't plug into the breadboard like it should be glowing green. And that's because the pins aren't set to the right connection gender. But that's really easy to do. Wow, the screen's very small. So if you go to connectors, you can set all of the connectors to male. And then while I'm at it, I'm going to rename these connectors to match the schematic. And then save. And it complains again. That's normal. Okay, so, and you can see it here, it has matched up all of the parts for me. So like SDA is SDA, SCL, this pin, it automatically does all the matching, so it's really sweet. And then this is the PCB view also, like pretty much it's all done. It's every pad is already connected. It draws the outline. It has this little thing, you can delete this, but I don't mind it. And then this is the breadboard view, and it also looks good. So under metadata, you can do all sorts of stuff like set the URL and stuff. So for example, MMA 8 451. I can put the URL here. 8. It was 8845. I guess it's 8451. Can put this down here as well. And that's it. And like that's it. You've created a part. And now it appears. There's 2 of them because there's one that I just saved. But now it like connects up nicely. And like let's say I want to grab a Uno. And I wire up ground to ground. I think SDA to SDA, SCL to SCL, and then VN to 5 volts. In the schematic view, it shows up. It's rotated, but it shows up. So that's nice. And then under PCB, you can also you can drag this around. You can like make a sub shield or something. and like that's it. It's pretty easy. So you can do it in like 15 minutes or so.
Okay.
Yeah.
Good work, Lady Ada.
Done. Time to go to Jupiter.
I think that's already over.
Oh yeah.
I think it worked out.
Who are these people?
I think these are people who aren't looking forward to the next election, so they are going to leave the planet.
Okay.
I think that's...
I'm jealous.
Yeah, that's what they're going to do. So they're leaving.
Okay.
Yeah.
Well, I did my
This
little
split screen
part,
thing.
little Fritzing part. So this little guy, now drawn very nicely.
Yeah. Okay.
Yay!
Okay. Good work, Lady Ada.
Thanks. Yeah, it's
Well-
like pretty straightforward. I mean, like you can grab the tool from our GitHub repository and try it out for
Yeah.
yourself. It's still, we don't have a tutorial yet. It's still very beta. There's a couple. We managed to get a metro generated, but a circuit playground is causing us a little bit of heartache. But we'll figure. The drawing is fine. The breadboard is fine. The schematic is fine. But the PCB, the file generated doesn't render at all.
Not yet.
Fun times with scalable vector graphics.
Good work, Philby. Good work, Lady Ada. This was something we've been hoping for a long time.
Yeah, so I've cranked out like 20 parts in the last couple days. Got through a bunch of requests. As we make new products, those products will get fritzinged immediately because it's like, if I have the file open, it's very easy to run the generator.
Yeah.
So that's kind of nice. And then we'll get through the backlog. Rather than taking 4 hours, it now takes like 10, 15 minutes. And it's like beautiful, and like these are like I think the best looking, detailed fritzing objects. I mean, like all the resistors and capacitors show up. I think that's kind of nice. The silk screen shows up perfectly as well. Do you want to show off the metro that we generated, or you want to get?
Let's save that for. You want to save that for the next show?
Sure.
Because we should probably do like some recaps of these throughout the week. Every time you do one, maybe we can even do like a super short podcast.
Yeah.
Okay.
Okay.
We'll do that.
All right. Well,
All right,
good
everybody.
night.
That's it. That was just Lady Ada.
Independence Day and Jupiter Day.
Yay, America. Okay.